away we go. All right, so here we are on the second part of the 5.2 lesson on sinusoidal functions, which means, again, that we're kind of ignoring tangent for right now. We're basically going to focus on sine and cosine. And here is, of course, the equations. This shouldn't look too terribly unfamiliar to you. It's the same as what we looked at way back in Unit 1, where the A value, let me just get a highlighter going here. Hang on, it's being kind of slow today. There we go. The A value is the vertical stretch. Now it's still the vertical stretch, but I call it amplitude. The B value is what we used to call horizontal stretch. It's still involved in the horizontal stretch. It's just that the horizontal stretch now tells us how much horizontal space it takes to make one complete cycle. So we call that the period. So B helps us to determine the period. C is what we used to call horizontal shift. We just call it phase shift now, but it's still the same thing. And D is what we used to call vertical shift, only now we call it the central axis value, because it just tells us where the center of our sine and cosine curve is. So we've given them new names, but they're still the same ideas that they were back in Unit 1. So let's kind of formalize how we find them. A, the amplitude value, is basically something you can find by taking the maximum minus the minimum and dividing by 2. Get it? It's halfway between the top and the bottom of the curve. D is the average. Actually, D is actually the halfway point between maximum and minimum. So this one I would find by taking maximum minus minimum and dividing by 2. Oh, sorry. I meant to say plus this time. This one's a plus. Right? This one here, think of it as the average between the top and bottom of the curve. So if the curve goes from here down to here, right, that value from there to there is A. And if I have, you know, a curve that again goes like that, the A value, oh, sorry, once again I keep kind of messing this up. The D is where this line is. The A is how much this height is. So how do you find the distance between 2 points? We'll take the top minus the bottom and then divide by 2. How do you find where you are between 2 points? You like the average of the 2 points. You just add up the 2 numbers and divide by 2. Period is, of course, 2 pi divided by the absolute value of B, or, oops, 360 degrees divided by the absolute value of B. And that means that B itself, kind of think of this as an equation up here. You can rearrange it and say that B is 2 pi divided by the period. So if I start with an actual graph and I want to figure out what the B value is, I just have to figure out how far it is from the start to the end, how far one period is, and then divide that into 2 pi, or again, if I'm in degrees, 360. Now, the C value, if I'm on a sine function, you remember that the starting point is on the central axis. So that's my starting point for a sine curve. For a cosine curve, my starting point tells me my C value. So the x-coordinate of the starting point is the maximum value. So whatever the x-coordinate is of the maximum value, I think of that as my starting point for a cosine curve. All right, let's try one. write the equation of the following graphs in the form y equals a sine b times x minus c plus d, or a times cosine b times x minus c plus d. All right, let's start with the things that are the same, whether I wanted sine or cosine. Let's start with figuring out a and d. First, let's find our max. Our maximum value here looks to me like it's 6. Our minimum value looks to me like it's -4. So, A is max minus minimum divided by 2, right? It's the distance from the middle to the edge, middle to the top or middle to the bottom. And that's going to be, now careful here, that's going to be 6 minus -4, right? Over 2, which is 10 over 2, which is 5. The d value, according to my little formula, is the average, which is max plus minimum, divided by 2, which is 6 plus -4 over 2, which is 2 over 2, which is 1. Now, if I got those two numbers right, I should be able to add them to my picture, and they should totally make sense. The d should cut the graph in half. So the d I found is 1. Yep, that looks good. That's my central axis. And this a value, this 5, should be how far it is from the line I just drew to the top or bottom. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They look good. So there we go. We've just found a and d. Now, to find b, I need to find the period first. And would you look at that? These bums didn't give me a graph that shows me an entire cycle. This doesn't even make it through an entire cycle, does it? But you know what it does do? It does make it through a half a cycle. From here to here, from dot to dot, is definitely a half of one full period. So let's use the letter P for period. 1/2 of a period of this graph happens in, I'll say uses, 2 units, and I guess we'll assume that those units are radians. And let's make an equation out of that. What does of generally mean in math? It means times. So 1/2 times period is equal to 2 radians. So how much would it take to make a full graph? 4 radians. Now you're probably looking, you really put a whole equation together like that to show us that if half of something takes 2, then the whole thing would take 4? Well, there might be questions coming up where it wouldn't be so easy to just do that in your head because you'd have uglier numbers. So having a nice little equation way to do it is helpful. Okay, so divide both sides of the equation by half, and yeah, half of what number makes 2? The number must be 4. So I would need 4 radians to make an entire wave from crest to next crest, or trough to next trough, or starting point to next starting point, whatever you want to think about it. So that means that the b value is 2 pi divided by 4, which is pi by 2. I have a, I have d, I have b. All I need now is c. Where is the starting point? Ah, finally now we have to make a choice. Would you like an equation in sine or cosine? I think if I was choosing, if I had my own way, it didn't say, it said or. I think I'd choose this to be a cosine graph. And there's people nodding their heads. They're seeing the way I'm thinking about this. What makes cosine the easier graph here? This graph has a starting point where I would expect normally the parent function of cosine to have a starting point. When I graph y equals cosine of theta, it looks like that. And so does this graph. It starts right there. So I actually don't even need a c value for a cosine equation. That's a q. And then I've misspelled equation. E. For a cosine equation, c equals 0. So I'm done. I'm ready to give you the equation. Y equals 5 for A. It's a cosine. The B value is pi by 2. And I'm not going to bother saying x minus 0. So I'll just say pi by 2x. And then d is plus 1. And there it is. That's the equation. Okay, but of course, we have to complicate life, don't we? What if I said I wanted a sine equation? Now what? Now I need to have a c value. Because normally, what do I expect a sine graph to do? I expect it to start right here. So I'm going to write for a sine equation, c equals what? What have we shifted by? And there's people going, oh, well, technically, since a sine graph, let me move over here and remind you that a sine graph looks like this. This point here, this starting point, and then you go up, is going to be over here. Where is it, though? Well, I know that sine curves have symmetry. So if this point is 1 unit to the right, this point has to be 1 unit to the left. How do you say 1 unit to the left? You'd say it's move over 1. So my sine equation is y equals same A, same B, but now my c is minus 1, which makes it plus 1. Remember the opposite rule for your horizontal shift? If you move to the left, you cancel the minus from the formula. If you like, if it makes sense to you, you of course could think of this as minus negative 1, right? And then of course the d value is still the same, plus 1. That's not the only way I could have answered this though. What if I'd have decided, no, for whatever my situation is, this has to be where the graph starts. This is time is 0. Time doesn't go backwards in my universe. The graph has to go that way. Fine. This is my starting point. What's my equation now? Any ideas? It's still sine.
It's in cos, by the way.
Oh, whoops. Thank you. That's a typo. I'm not typing, I'm writing, so I guess it's a righto. That was a righto. Sorry, thank you for being awake. All right, back to what I was saying. Suppose I have no choice. I've been told I need a sine equation, and I've told I'm not allowed to have it shift horizontally to the left. That's my starting point. But what's my equation going to look like? I actually have now added a new feature to my equation. Because what does a sine curve usually do? Oh yeah, it usually goes up from its starting point. What's this one doing? It's going down from its starting point. What does that add to the equation? It adds a negative. Where does it add the negative? I put it on A, but it actually wouldn't matter if you put it on B, because we actually looked at that yesterday. It doesn't matter whether it's a horizontal reflection or a vertical reflection. I think A is the smarter place to put it. So I could say that it's negative 5 sine, thank you very much, pi by 2 times x minus 1, because I shifted 1 to the right. And let's say I'm an engineer, and let's say that whatever is going on, I've been paid to do the math on something, and the people who are now going to give this equation to the underlings who have to put numbers in it, my supervisor goes, no. First I came up to him and I said, here's your equation, sir. And I gave him this lovely cosine equation. He hands it back to me. He goes, no, I wanted a sine equation. And then I go back and I figure out the sine equation. And then he hands it back to me again. No, I don't want a negative in the start of the equation. Fine. How about I consider that maybe the starting point's over here then? Now my equation is y equals 5 times the sine of pi by 2. And instead of shifting 1 to the right, we shifted 3 units to the right. As weird as it sounds, all of these things are the same equation. And I can prove that. Let's put them on Desmos. Do I have a Desmos open? Oh, I don't even have an open right now. Okay.
Shouldn't right be negative?
Nope. That last one should not be negative. And I'll show you why. Oh, wait a minute. Did I actually put in, unless it's not the negative I'm thinking of. Yes, this should be a negative. Thank you. I thought you meant in front of it. That's a mistake. Righto number 2 today. Ah! That's not the pen. Hang on. Thank you. That's better. There. Those 4 equations should be all the same thing. Let's prove it. Okay, so what kind of a graph do I want? Okay, I better get a keyboard to type with here. I want y equals, and okay, let's graph the first one. Let's graph that nice cosine graph I had first. So it was 5 cosine, and then I had pi. Notice when I type in pi, it just switches to a pi, which is very cool. Divided by 2, then move over and get out of the denominator there. So I just hit the arrow key, and then x, and there we go. There's my graph. I don't have to change the scale on this. I can see the curve very nicely. Now, except I do have to hit the +1 part. +1 there, shifts up. Okay. Now, according to my work, y equals 5 sine of, open a bracket, pi by 2, and then open another bracket, and if what was my first one again? Oh yeah, that was where I shifted it 1 to the left. So x plus 1, and then go to the end of those brackets and go +1, and as you can see, it's red, it's blue, it's red, it's blue, it's the same graph. And I don't feel like typing this much anymore, so I'm just going to copy paste. Control C, Control V. And now, why don't I, instead of going +1, why don't I try going, what did I do first? I made this a negative, and then I went -1. It's green, it's blue, it's green, it's blue, it's the same graph. And then again, I had a very, very picky supervisor in my engineering job. So, oops, guess I don't need that many y equals, do I? So this time he says, no, I don't want it, it can't shift to the left. That will confuse the people using the formula, he says. So I say, fine, how about I shift it to the right? And it's purple, it's green, it's purple, it's green. They're all the same. Now, as you can see, there's infinitely many equations I could make here that would make this work, right? Because I could shift it to the 3, I could shift it over to this 7. It wouldn't really matter, right? All of these are going to work. So when you're doing this, I think use common sense. Common sense told me that my favorite of these multiple answers here is the first one, because it was the easiest. I didn't even have to think of a c value. After that, I kind of like the one where I don't have to deal with a negative. Right? So there we go. So that's how you do these. You look at the equation, you figure out the numbers, and then, of course, you can always use Desmos to check to see if you've got it right. Unfortunately, I can't let you do that on the test. All right. Moving along. Let's try another one. So, maximum first. What is the maximum of this thing? It looks like it goes up to -1. What is the minimum of this thing? The minimum is -7. Okay, so what is the A value? The A value is the distance from here to here, which I can pretty much just count off the graph. If I can count it, I'll just count it. So the distance from there to there is 3. But again, if I needed a math way to do it because it was far too complicated a graph for me to count, I might say that, okay, that's max. The A one is the minus formula, so max minus min over 2. which would be -1 minus -7, all over 2, which is -1 plus 7, which is 6 over 2, which is 3. Okay? And the d, well, again, I can kind of see it. There's my central axis. It happens at -4. But again, I could use the formula of max plus min divided by 2, which is -1 plus -7 all over 2, which is -8 over 2, which is -4. And whoops, I just made the page jump for no reason. 4, there we go. Okay, any questions on how I got A and D? Certainly on this one I can just read them. But keep in mind, those little formulas always work. Can we have them on our formula sheet? No, you can't have them on your formula sheet. Whoever asked that question. All right, next. Those are the two easy numbers, the A and the D. Now the ones we got to think about. What is period? Period here is, it will make an entire wave from start to finish in 2 radians. So the period's 2. That means that my B value is 2 pi divided by 2, which is pi. All right, what would we like for a C value? Well, in this case, I think I want a sine curve, because it kind of starts the way a sine curve does, at the 0, not at the maximum. But when I start a sine curve, I go up then down. This one's going down then up, so A, so I'm going to pick a sine curve, which means that C equals 0, but A is negative. Why is A negative? Because it goes that way. It's going down first. So that's my simplest equation here. Y is equal to negative, A is 3, B is pi, and then x, I didn't really need that extra bracket, and then minus 4. So that's my equation. What if instead of sine I chose cosine? Just so that we understand that we can do it. For cosine now, if I don't want a negative out front, that's where a cosine graph would normally start. So C would be what? Looks like I have shifted over 1.5. So I could say that I shifted positively, right? I shifted to the right by 3/2. Or wouldn't this dot be over here? I could say that C is -1/2 too, if you like. Which one do you like better? I don't know, a half's a simpler fraction than 3/2. I think I might go with this guy. It's the closest physically in terms of how much of a shift I made. So I'm going to say, I'm going to use that one. I've chosen not to use this one. Nothing wrong with it. I didn't mean to obliterate it like that. Now I feel bad. I just made the choice that I wanted the smallest fraction I could. So y is equal to 3 for A, cosine. B doesn't change. B is still pi. Only now I have x minus -1/2, right? Because we shifted to the left. Close brackets, minus 4. And again, I won't bother doing this every time because this will slow my lesson down to a crawl. But feel free later on to punch both of those equations into Desmos. They should be exactly the same line. Okay? Would it freak you out if you were doing your homework, it asked you for a cosine question, and the answer key said this? Are you okay with the fact that you can just factor, oh, hang on. That's not what I meant to write. Let me do that again. That's what I meant to write. Are you okay with this being exactly the same thing as that? Just unfactored? Right? Pi is just a number, right? You can factor out pi the same way you can factor out any number. Okay. What's really cool about this stuff is that I actually don't even need to give you the graph. Check this out. Suppose I just give you points on the grid someplace. The point -2, 7 is a maximum of a sinusoidal function. The next consecutive maximum, consecutive means in a row, so there's no more maximums between these 2 points. So the next consecutive maximum is at 6, 7, and the range of the function is -1, 7. That's all the information I need to make the equation, believe it or not. Let's see if I can show you why. The range of the function tells me how high and low it goes. So this is the lowest point, so this is my minimum. And this is the highest point. This is my maximum. I kind of knew 7 was the maximum, by the way, because that was the coordinate there, but I did need to know what the minimum was. So notice that that already tells me what A and D are. So A, of course, I can find by going the min minus the max. So 7 minus -1. Watch those negatives. Little integer errors give you wrong answers. 7 minus -1 is 8. 8 divided by 2 is 4. And D, you get by finding the average of the maximum and minimum. So 7 plus -1 divided by 2, which is 6 over 2, which is 3.
Isn't it max minus minimum?
That's what I did. 7 minus max minus min.
Okay, yeah. You said min minus max.
Then I said it wrong, but I wrote it down right.
Yes.
There's what I'm saying, there's what I'm thinking, there's what I'm writing. The chances that all of those things actually agree with each other all the time is quite low. Sorry about that. Thanks for noticing. Okay, what was I doing? Okay, I got A, I got D. What should I do now? Ooh, let's work on period. So what do we know? We know that the next, from maximum to maximum, is one entire cycle. So we know the period goes from -2 to 6. So I'll say that. Period completes one cycle from -2 to 6. And I know there's people who would go, well, wait a minute, -2 plus 6 is 4. So the period is 4. No, it isn't. What is the distance from -2 to 6? Do you get that it's 8? You want a little number line to look at that, right? Think about it. If you start at -2, -1, 0, 1, 2, 3, 4, 5, 6, obvious now that that's a distance of 8 things, right? You okay with that? I don't know that I have a little formula for that or anything. I think for me, it's just kind of common sense. Okay, so there we go. So the period's 8. So that means the B value is 2 pi divided by 8, which is pi by 4. So there we go. We finally got ourselves a B value. We have the A, we have the D. Now, what kind of an equation do we want? Well, let's think about this. If we are thinking in terms of a parent function, well, a parent function, of course, is going to start at a maximum when it's a cosine. So this one has a maximum at -2. So why don't I say that I'm going to do a cosine graph, and my C value is -2. That's the easiest way to do this question. Okay? I could try to find a sine curve instead, but then I'd have to figure out where the nodal point is. Because remember, a sine curve starts on a nodal point. That's actually not that hard to do. Because think about it, I know that it completes an entire cycle in 8, so the nodal point happens 4 units from this -2, right? So, or wait a minute, let me think about that for a sec. No. It does a complete crest to trough. So sorry, it has its minimum halfway between these 2 points. So it has its minimum 4 units to the right, which means it has its node 2 units to the right. So there we go. Its sine value would be 2 units to the right of this point. So actually, C would be 0. This thing actually must cross its nodal point right on the y-axis. I can kind of visualize that. If you can't visualize that, by all means, once you already have D and B and A, you could make yourself a pretty good sketch. Right? You could sketch this. This is a nice review of what we did yesterday. And this is one of the things I was saying when I said maybe yesterday's lesson makes more sense when we do today's lesson. Because now you can kind of see what we're getting at here. Let's make a quick sketch. So most of this graph is positive. We only have to go down to like -1 here, right? And our D is up at 3. So 1, 2, 3. And then our A value is 4. So 1, 2, 3, 4. And that's why I know I have to go down to -1. And okay, so what do I know? At the point -2, 7, so -1, -2, 7, I have a maximum. My next maximum happens at 1, 2, 3, 4, 5, 6, 7. And that's all it tells me. But when I know its shape, that actually tells me quite a lot. Because I know that it's going to make its minimum. This is its maximum. This is my minimum. I know it's going to make its minimum halfway between -2 and 6. And halfway between -2 and 6 is 2. So there's the minimum, which means that the nodal point's right there. So it's going to look like this. And then go 2 more over and make another node. There's my graph. So as you can see, it's like a cosine got shifted 2 units to the left, or it's like a sine didn't get shifted at all, but A is negative again, right? Because it's going down first instead of up. So armed with that information, I can make you either equation you want. I think I'd have made, if I'd have had my choice, I'd have made the cosine one, because it was easier to visualize this as a cosine since I started from a maximum. So y is equal to 4 cos, because A was 4, right? 4 cos. The B value is pi by 4. And the cosine needs to have a minus -2, which is +2. And the D value was +3. So there's the cosine equation. Or I could give you the sine equation. A still 4. Oh, but it's negative. Let's make the negative first here. -4 sine. And this is a slightly simpler equation. I can just say pi by 4 times x. And then +3. Okay? Both good. And again, feel free to graph those yourself. You'll see they're exactly the same line. All right. Who do they think they're dealing with telling me this is tough? Okay, fine. It's tough. We'll believe them. Let's give it a go. Give it a try if you like a challenge. I love a challenge. I'm up for a challenge always. Okay, you know what makes it a challenge is, what the heck am I supposed to do with 0.79? I guess is that what a quarter of pi is? Pi divided by 4, 3.14157 divided by 4 is 0.79. Very nice. Okay, fine. So this is actually a quarter of pi. Okay, that's good. Well, I'm still going to start the same way I started the last one. What's my minimum here? My minimum is -5. What's my maximum? My maximum is -1. So that tells me that A and D are what? So I'll let you think about it. Give me A and D. And again, you could probably just read them off the graph. I guess I'm assuming that this is a nodal point, and it doesn't tell me that it isn't, but I guess I'll assume it is. So there's D is -3, and A is the distance from here to here, which is 2. Now here's what makes this kind of tough. The period. Well, you might be going, well, I can count from here to here, but you know, it doesn't actually give me this dot. The dots it gives me are here and here. So I'm going to play along. I'm going to say, all right, I'll figure out the period from your dots, and that's why they think this one's a challenge. How much of a period is it from this dot to this dot? Well, it would be 1 1/2. So 1 1/2 periods equals, all right, well, let's count by quarters of pi. 1, 2, 3, 4. So 4 quarters of pi, which is 1 pi, right? The distance from here to get, again, do you get how I know that? If this distance here is 1/2 of pi, then this distance has to be 1/4 of pi. So this is 1, 2, 3, 4 quarters of pi, and 4 quarters is 1 whole. So 1 1/2 times pi or 1 1/2 times the period is pi. Might as well make that a mixed, or an improper fraction. And then maybe this is the hard part. How do you solve that equation for p? Quick, how do you divide by a fraction? Some people are giggling at me here, but you know what? I meet grade 12, so forget this rule. How do you divide by a fraction again? That's right, you times by the reciprocal. So the period is 2 pi divided by 3. Get it? I have to times by 2/3. That is kind of tricky. So that means that B is 2 pi divided by 2 pi divided by 3. What? Because remember, B is 2 pi divided by the period. So once again, that's going to be dividing by a fraction is timesing by the reciprocal. There you go. B is 3. We have A, we have D, we have B. Now all I need is a C, and to make the decision as to which sine or cosine you'd like. Which one's simpler? I think sine might be simpler, right? It's about the same. I have to go 1/4 of pi to the left to do a cosine, and I'd have to do 1/4 of pi to the right to do a sine. So it doesn't matter. I'll do sine. So y equals, what was A again? 2. It's positive because I'm starting here and I'm going up, so it's a positive this time. 2 times the sine of, we just found out that B is 3, and it's going to be x, let's see, what am I doing again? I'm going pi by 4 to the right, and the D value is -3. So there we go. If you would prefer the cosine equation, what would it be? It would be, let's move it, the two, I'm going to start here because it's closer to my axis than that one. So that's going to be still a 2, but now it's a cosine, still a 3, but now I have shifted pi by 4 to the right, or sorry, to the left, which is a plus, or minus a negative, which is a plus. And it should make logical sense that these two equations are the same as each other, because remember, we learned when we very first, using the bicycle wheel, drew the difference between sine and cosine, that the difference between them is a phase shift, a horizontal shift of pi by 2, of 90 degrees. And how far apart are those two numbers? They are pi by 2 apart. So that should make logical sense. All right. Why don't I, for the people who are working at home, why don't I stop the video for a few minutes and let you try these, and then we'll reveal what the answers are in a few minutes. So, okay, so I'm going to pause my video here. And we're back. Did you finish those first two sine examples? And did you get that A was 1, D is 0, B is 2, and C is 0, which makes for a fairly easy equation. If A is 1 and C is 0, it gives you the equation, just sine 2x. Now, this creates an interesting thing that we should talk about. Do I need to put brackets around here? Like, without brackets, how do I know that isn't the sine of the number 2 and get that answer and then times by an x rather than the sine of 2x? I guess technically I probably should put brackets around there, but most people would assume that sine of, and then I don't have anything until I see a plus or a minus, all of that stuff is the angle. So if you didn't put the brackets there, I would assume you meant that that's all one angle. So there's your first answer. The second one, A is 3, D is 0, B is 1, C is 0. I would, however, say that since this thing is going down first, that it's a reflection, so I'd put a negative on the A and say that y is equal to negative 3x sine x. Right? B is just 1 because the period is 2 pi. 2 pi divided by 2 pi is 1. I don't need to write a 1 in front of the x. I know it's there. Okay? All right. So now for the next 4, they want them all in cosine. So we're kind of out of time. So you're going to try these ones yourself. I'll just sort of add this to the homework. And I actually already have the key for this on the blog. If you go to my blog, there's my blog. The key is already, hang on, I think it's already here. Yeah, there it is. You know what, I say do page 16, but I should say do pages 15 and 16. And here is the key. I think it actually has the key to page 14 too. So there we go. There is our new assignment there. And then finish the 5.2 worksheets in the booklets. And you have till Monday to do all that. It's only Wednesday, I know, but we're not going to have regular classes tomorrow or Friday because of wellness days. I won't be too far from Edsby, so on my computer, so if you're getting hopelessly stuck on things, feel free to message me, and I'll try to help you out. Okay? That's it. That's today's lesson.